A very good morning, good afternoon, good evening to all my dear friends, participants and students. Welcome to this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Model. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you know, the three broad areas being covered in this course of 12 weeks, 60 lectures, 30 hours, and the topics are forecasting, the first one, regression, the second one, and time series, the third one. We are still in the fag end of linear regression model, and we are week 9, lecture number 44. What is the coverage? So, the coverage, now we are changing our discussion totally. For a whole set of days, we are discussing about regression models, loss functions, estimate, trying to find out the Linux loss, squared error loss, balance loss. Now, we will change the frequency and the discussion altogether. We will come into logistic regression with very simple concepts and one problem. Then if time permits, as I always say in the coverage, I plan a lot of things, but as the discussion goes on and the qualitative way it is being discussed with the problems, we are not able to give the coverage, but be rest assured the slides would be perfect and up to date. Now, another thing which you would have noticed and which I did mention when we started this course, that all the problems, all the solutions, all the calculations are all very simply based on Excel, nothing else. If any extra packages or software packages are going to be used, I have purposefully desisted from utilizing that, because once you understand, and another thing, for all the topics I laid very special emphasis from the basics, like trying to find out how you find out the betas, how you find out theta, what is the, I am talking about the regression part, how do you find out the value of R square, what is adjusted R square, what is the conceptual difference between adjusted R square and R square, what is the mean value or expected value of beta, what is the expected, what is the variance of beta, what is the best estimate of sigma square, which is sigma square is the error of the variance of the errors. Now, what are the different assumptions for regression models, and similarly I did for forecasting also. So, here also I will discuss more of the concepts, and problems will be very simple. Now, what is logistic model? In logistic regression model, the answer to this question is very simple. In logistic regression, your dependent variable, which is y, is only binary 0 1, and what I mean by 0 1 is not the answer, is basically based on some probability. But when I come to the concept of the x are the variables, they are the variables as we have considered in the regression model, but here the output is totally different. So, let me continue reading it. Logistic regression is used whenever dependent variable is binary 0 and 1. There can be multiple variable logistic models also where the answers need not be 0 and 1. So, in that case you can formulate the problem as different categories of probabilities, but obviously the probability is being between 0 and 1 and the sum of the probability is always 1. So, that concept of multivariate case we are not going to cover in this course. Logistic regression estimates the probability of your dependent variable to be 1. So, when y is 1, when something happens, what is that decision? That you have to decide and verify y is 1, with some probability you will take the decision. Y is 0 with the other probability 1 minus the previous probability. When y is 1, consider the probability is 60%, when y is 0, the probability 1 minus 60% or 100 minus 60 or 1 minus 0.6 is 40%. When something does not happen, so that means it is binary, only two outcomes. Logistic regression is one of the most important analytical tools used in social and natural sciences, because in many of the cases in social sciences the answer is qualitative. Yes, you take the decision, don't you take the decision. So, or yes, this path should be followed, or no, the path should not be followed, or with some probabilities. So, hence it is much more interesting to use logistic models and try to understand the utilization of logistic in many of the social problems. So, this is important, which I said does not happen. Now, a little bit more background. This is for your interest. In natural language processing, logistic regression is the baseline, fundamental thing in supervised machine learning algorithms for classification. When you classify, depending on the output, you classify in category 1, 2, 3, and obviously there are characteristics for the categories based on that which you do. So, let me continue reading it. In natural language processing, logistic regression is the baseline supervised machine learning algorithm for classification and also has a very close relationship with neural networks, because neural networks which you remember, or someone remember in the sense if you have done, you have nodes, the connectivity, the layers, hidden layers, depending on the transfer function, depending on the probabilities. So, this neural network and logistics would basically be not a mirror image of each other, but they give a lot of information from the logistic one and how you can build up the neural network. A neural network can be viewed as a series of logistic regression classifiers stacked on top of each other, because in neural network what we do? So, you have neurons, and based on connectivity and based on the transfer function, based on the input output, a path is taken. So, if the first path is taken, which means the second path is not taken, or the third path is not taken, and you proceed accordingly. So, if you proceed accordingly in the same way in logistic regression with probability of y is equal to 1 or y is equal to 0, you take only one path. So, if you follow that concept of logistic, yes, no, good, bad, will take that, will not take that, which means it is the same way how you follow the neural networks as the flow process happens depending on the information set. The goal of binary logistic regression, because there are two outputs, is to train a classifier, what you want to do, whether you want to take the decision, that can make a binary decision about the class of new input observation. So, you have trained your model, as we all know in the AI/ML, you train your model. So, when you have that neural network and which is based on a stacked up different type of baseline logistic models, you can train that logistic model based on the initial set of inputs, and as it gets trained, then the probability of an error, because error can be there of classifying the right thing into the wrong category or the wrong thing into the right category. So, to give an example, this is an example I am talking about, and this can be modeled in the case of hypothesis testing also. If you have done DADM 1 course, there was one example which I very simply applied and considered, where you were trying to discuss the problem, or we were trying to discuss the problem of error of type 1, error of type 2, alpha and beta, if you remember. So, in this, where the error comes, like you are trying to sort out application for bank loan, and this is the same example which I had given there in DADM 1. So, people are filling up their papers based on the scores. The scores can be based on whether they have a job, whether they have a house, whether vehicle, whether they pay income tax, whether the house is their own or rented. So, based on that, points are given and the paper is submitted by the applicant for the loan, and the bank manager processes it. Consider the cutoff point is 60. For any points to a person who is applying for the loan, more than 60 give the loan, less than 60 the person is politely told that loan cannot be given to him or her. But there can be misclassification, means due to some error when the points were given to the loan applicant, a person who is not eligible to get a loan is given a loan, which means they would be bad debt later on. The loan given may not come back. So, this is one type of error, which is loss in qualitative sense. And other type of error can be a person who is actually eligible for loan, but due to some error the person is denied the loan, which means there is business loss, and the person not being given the loan means you are losing your business. So, this is of the other type of error. Now, in hypothesis testing, if I mention these two errors as alpha and beta, type 1, type 2, then trying to, and this is important, listen to me, trying to minimize both of them at the same time is not possible. So, what you do is that you try to minimize the sum of them, or you keep one of them fixed and try to minimize the other. So, in general, for hypothesis testing, we consider that given the level of beta of type 2 error, you try to basically, for the problem, you try to minimize the type 1 error, which is alpha. So, in the same way, as you train your network, as you train your model, the errors would be there, but you are trying to minimize this error to the maximum possible extent based on the misclassification. So, if you have binary, so the classification can be from 0 to 1 or 1 to 0, two type of errors. But if there are multiple classifications, then the errors basically may increase, which I just wanted to mention accordingly. Now, as in neural network you use a transform function, one of the important functions is the sigmoid function. Now, what does the sigmoid function do is basically it's a function where you get an input and it converts into a output which is between 0 and 1. Why 0 and 1? Because that would give you the concept of probability, and why probability concept is that if you remember from DADM 1 course if you have done, or any basic probability course you have done, the cumulative distribution function has some properties which is prevalent for all the distributions. Number 1, the cumulative sum is between 0 and 1. It is an increasing function, monotonic increasing function, because probabilities cannot be less than 0. It can be 0 or between 0 and 1. So, if you keep adding the probabilities, the cumulative function will slowly increase till the maximum value of value is 1. And also for the case, as I mentioned, is monotonically increasing, that means as you define the sets, define the events, including more and more increasing the event in its scope, that means the definition, the probability would not decrease. It may remain the same, but it may remain the same or increase. And obviously, the property we all know, that null set probability is 0, all these things. So, sigmoid function basically transforms that information set of x variables which you have into a sigmoid function which gives you a probability, and that cutoff probability you have to decide based on the points. Now, sigmoid classifiers helps us to make the decision, and I am using this as a classification function, that I will take the function, it is well known, is 1 minus e to the exponential to the power minus z, and z is the function which you are going to take, and I plot that considering the value of x is on the x axis and the value of the sigmoid function which is y is given in the y axis, and the values of x are from minus 4 to plus 4. This I am pointing out because you will immediately see it within few seconds. Now, if I increase or decrease the range of x, the sigmoid function property is always between 0 and 1, because if you see here, the value is 0, value is 1, always bounded like the CDF function of any distribution. But the shape of the sigmoid function, which is S shape, so S would become more stark or it will be more flat as shown here. And in the case when you are taking the domain or range of x to be quite negative, like minus 100 to plus 100, what happens to the sigmoid function, that is also important, I will show. but obviously the crux of the discussion remains it is like a function which is being utilized to transform the variable set or variable x into the sigmoid function with the values between 0 and 1, because that will give you the probability. If I take a sigmoid function value of x being minus 20 to plus 20, you see now it turns out to be not a flat S, but more of a stark S. Interestingly, I will plot it with the green color. As the value of x decreases, decrease means, so that would become, I will use the green one. So, do not concentrate on the domain of x. So, how the function would look like is a flatter one, as we have seen. So, I was not able to draw something like this, which I saw in the last slide. Now, if the domain of x is larger, minus 100 to 100, here it is minus 20 to 20, if I take minus 100 to 100 or minus 200 to 100, plus 200, minus 500 to plus 500, the function would look like this. Just a peak, jump this. So, the S value, if you see the green one much flatter, the red one is slowly changing depending on how the x range changes, and x being from quite a low value of like minus infinity plus infinity is just a peak. And this property all of you would have checked in your basic sigmoid function or this transfer functions. If somebody is doing electrical engineering, mechanical engineering, this type of transfer functions are used, and this type of transfer functions, sigmoid and others, are used in artificial neural network or neural network problems. This I thought before I solve the problem, some information of the sigmoid function should be mentioned to you. And remember the equation y is equal to 1 by in the 1 in the numerator and then denominator 1 plus exponential to the power minus x. Now, let us go into solving the regression, logistic regression model. Consider x, the variables are 1 from x1 to xn, like in the case of multiple linear regression, you had 1 y and multiple x. In the same way, you have y values of 0 and 1 and multiple x, x1 to xn. Technically, for clarity, I will change the slide, I should mention as 1 to p. So, that confusion of what p is and what n is, that should not come up here again. N is the sample size, p is the number of variables. Logistic regression solves this task by learning from a training set and a corresponding vector W1 to W is given and a bias term is there, which is the intercept. Now, this weights is a very interesting fact. So, if I have x1 as some variable and I want to pay more attention to it, which means I will give more weightages to it. If x2 is a variable which is not that important, hence I will assign less weights. So, it is in some way the concept of beta which you have seen. So, beta 1, beta 2, beta 3 are the regression coefficient. Beta values being higher, which means per unit change in x, the corresponding per unit change in y is high, because for beta is high, which means the effect of x on y is much more if beta is higher. In the same way, weightages being high, which means the overall correspondence or overall effect of that particular x is signified by the weightages which is on the higher tone. And z is called the logist and the inverse of the sigmoid function, which is given by this, and will utilize this function. So, if you see W transpose x is, W is a row vector and x can be considered as a column vector. So, when you multiply W transpose, which is a row vector, with B, x is a column vector, the value is a scalar. Scalar plus B, which is the intercept, will give you the z value, which can be considered as inverse and sigmoid, and based on that we try to find out the probability. Now, here I will give the end results. and we will utilize this results to solve our problem. So, probability of y is equal to 1 in category 1 is given by this sigma. I will call it as a function based on w, x and b, and I am defining that function as sigma, and the probability will be given by this one, which is 1 by inverse of that, 1 plus 1 divided by 1 plus exponential of minus w t x plus b. If you see in the sigmoid function, it also that same fact, you had 1 plus e to the power minus x, and this x or say for example whatever function you use, that is being given out here. Based on that you will get, and when you convert that, so this sigmoid function is being utilized to convert that, because if you remember z is a inverse of that. So, when you utilize that, you will be getting the probability that p or y is equal to 1, which is a probability that it is assigned to category 1, where the value of y is 1, and when p is equal to y is equal to 0, it is 1 minus that. So, once you put that, because the probability sum is 1, so 1 would, if the probability of one value is alpha, the other value would be 1 minus alpha, and that you are basically calculating from this 1 minus sigma function of this, which if you put out here 1 minus this gives you the actual value, which I will mark in blue, and this is the probability it is assigned in category 2. So, it is y is equal to 1 category 1 left hand side, y is equal to 0 category 2 on the right hand side, only two categories, binary. Hence, probability y is equal to 1 is alpha, probability y is equal to 0 is 1 minus alpha, and you can consider the logit value of p given as p value which you find out, and is sigma inverse, and we find out. To create a probability, we pass z through the sigmoid function and get the output as sigma z. This is what we are doing. Once we get z, you pass on to the sigma z function, which is a sigmoid one, and get that output, or if the sigmoid function is given, you can reverse map, and this is what is also important for reverse mapping. Finding, given the probability, finding out the values is also important, which for reverse mapping we are not going to consider. We will only consider given x, given w, we will just map it to the sigmoid function and get the probabilities. The sigmoid function, so these are some technicalities I will just read. The sigmoid function named because it looks like S is called the logistic function and gives the logistic regression its name. Using this term logit for x, z is a way of reminding us that by using the sigmoid to turn z, actually z can range, x can range from minus infinity to plus infinity, as you have seen. We are just converting that into the probability sense, as the probability values are all between 0 and 1. So, let me read it. So, using the term logit for z is a way of reminding us that by using the sigmoid to turn z, which is between minus infinity to plus infinity, into a probability, we are implicitly interpreting z as not just any real numbers, but specifically in the sense that it is in the range of 0 and 1, which is a probability sense. Now, let us consider a very simple problem. Consider a binary sentiment classification on a restaurant review. Whether to assign a plus and minus to the feedback, based on that feedback, the person or the reviewers, when they read this feedback, they will take the decision whether to visit that restaurant or not, and this is being done by an individual. Consider there are 6 features, and features can be anything. Features can be, say for example, decor, feature can be food, feature can be music, feature can be cleanliness, feature can be light, feature can be comfort level, feature can be ambience, anything. So, I am and they are need not be quantitative, they will be qualitative, and based on that qualitative factor they will be assigned. So, there are 6 features and we are assigning them as a vector x1 to x6. Here 6 is p, actually which I mentioned that it was n, I will correct it in my slides, because that confusion of what is n and what is p should not change or should not again crop up in this logistic part. It should remain as p throughout the discussion. What is the review given? The restaurant has average food and the menu is not great, plus food was not warm. So, why was it so enjoyable? For one thing, the ambience was good. Another nice touch was it is spacious, less crowd, plus there was good music. I enjoyed the music and I am sure you will also like it. This is the review, and based on that I will take the text keywords which are important and assign the variables or 6 features accordingly and then map it. So, this is the logistic regression framework of the variables and the definition. What is x1? So, if you remember, I had mentioned a few minutes back that it can be ambience, it can be decor, it can be the what is the temperature, not hot, not cold, loud noise, less loud noise, music quality being good, lighting being good, it is being very comfortable, good set of people who are serving the food, everything being there. So, those are qualitative based on this. The statement has been given, which was in the last slide in highlighted part, and based on that the set of the variables are being classified in this table. In the first column you have the variables marked x1 to x6 and the definitions are given. As I said, the definitions are all qualitative. So, if the count or if the positive words or lexiconic words are used, good, very good, excellent, nice, good decor. So, all these words are appearing in the statement, then you will assign a value, and those values if you add up in this paragraph, the value comes out with 3. That means 3 times those nice lexicon words in review of positive sense had been used. X2 is basically the negative lexicon words which are there in review, like if the food is not warm, or ambience not good, or loud music, very cold, very warm, not at all good set of people who are serving the food. So, those negative words if they are counted, that comes out to be 2, if you see row 2. X3, if no word is used or 0 otherwise, if you assign 1 if no is used and 0 others, which are very categorical, yes, no, good, bad. So, that number is 1. Number of pronouns being used not in the positive sense or negative sense is there, which is 3 in number. If exclamation, very good, very bad, question marks, all these things are used, then you assign points, which is x5, which is 0 in number, and you find out the word count in the document, which is 57 in that word. If you see, and if you download the Excel sheet, if you count, there are 57 words, and logarithmic of that is 4.0431. We will use the last column for our calculations. Now, the weightages have been assigned. The weightages are depending on the importance. If you remember, for x1 positive 1, very good, you are assigning a weight of plus 2.5. x2 negative 1 does not give very good meaning, you are assigning a heavy number, but on the negative side, which is minus 5. And for others, it is given as minus 1.2, 0.5, 2.0, 0.7. And if these points are being assigned by the decision maker himself, to what level. So, if the positive points are very good to him, so he or she will assign a point of not weightage of not 2.5, that 2.5 can change to say for example plus 4.0 also. If the negative ones are of huge negative implication, so rather than minus 5, it can be minus 7 also. So, these have to be noted. So, if you note down the values, let us check the weights. So, the weights are 2.5 minus, I will write minus this. So, this is minus 6.2 and the plus values are 0.5, 2.0 and 0.7. So, the values comes out to be 3, 4, 5, 5.7 plus 5.7. So, the weights concept are this minus 6.2 and 5 minus plus 5.7. Obviously, the weightages are more tilted towards the negative one, and the x values which were found out in the table in the last are given as 3, 2, 1, 3, 0. 4.04 is basically ln of this number of words. The intercept value I am taking as 0.1, and based on that assign probability of y is equal to 1 given this x values. When I give in sigma, I plot it in the sigmoid function, which you can do very simply using Excel sheet or any. The value comes out to be 0.73. That means the probability is 73% that given x concept, the positive notion is 73%. And when I put the same weights x, b for probability of y is equal to 0, it is 1 minus that sigma function. When I put it, the value comes out to be 0.27, and if you consider addition of probability y is equal to 1 plus y is equal to 0 should be 1 as it is. 0.73 plus 0.27 comes out to be 1. It is a binary classification. If you have more than 2 classifications, obviously the sum should add up to 1 there also. So, with this I have considered a very simple logistic model, and given the sigmoid function, once the sigmoid function you are able to understand whatever I explained and utilize this, given these weights, given the x and how you classify, you will be able to do the problem accordingly. Thank you very much and have a nice day.